Hello friends, welcome to Maths Nerd.
Today, we will learn about geometric progressions, their values and their sums. So, before learning about a geometric series, we should know what are geometric series. So, basically, a geometric series or a geometric progression or a geometric sequence, which is another name for it, is an infinite series in the form of a plus ar squared plus ar cubed plus ar raised to 4, and this the power of r increases one by one in every step. So it means that first you have to take any number a, multiply it by another number r, add the product to the sum of 2a, and then take that number ar, multiply it again by r, and then add it to the previous sum, and so on. For example, 2 plus 4 plus 8 plus 16 plus 32 plus 64. So here a is 2 and r is also 2. So we can see that a is equal to 2, then ar is equal to 2 into 2 4, then 4 into 2 8, or 2 into 2 squared, that is 8, 2 into 2 cube 16, and 2 into 2 into 2 raised to 4 is 32, and 2 into 2 raised to 5 64. Now let's see some interesting formulas about it. So first we will find how to find the nth term in a geometric series. That is, if you are asked to find the hundredth, or not hundred, suppose tenth, then you won't sit and add and add and add, or multiply and multiply for each term. There is a simple formula. Let's see how it is derived. So the first term is ar raised to 0, because r raised to 0 is 1, so this thing is just a. Then this is ar raised to 1, and r raised to 1 is just r, so it is ar, and from here we have already seen. So you have noticed that the r's power is 1 less than the term it belongs to. Therefore, for nth term we can write the formula as series nth term is equal to a into r raised to n minus 1. For example, if n would have been 7, that is, this would have been the 7th term, then the power of r would be 6. Like in the 6th term, it would have been ar raised to 5, and in the 7th term, it would be ar raised to 6. Let's see this in action. So we have to find the 7th term in the series. So when I had given you an example of a geometric series, there were simple whole numbers, but they can be also rational numbers. But the formula remains the same. So here 1 upon 3 is a, because it is the starting number, and what multiplied by 1 upon 3 is 1 upon 6. Well, it's 1 upon 2, so 1 upon 2 is the r. So first we have written our things, and we have to find the 7th term. So here n is 7, and then we'll plug in the values into the formula. So the formula is the nth term of a series is equal to a into r raised to n minus 1. So the 7th term of the series is equal to 1 upon 3, that is a, into 1 upon 2 whole raised to 6, because 7 minus 1 is 6, and since we have seen in exponents that a upon b whole raised to m is equal to a in a raised to m upon b raised to m. So 1 raised to 6 is 6, and 2 raised to 6 is 64. So we have 1 upon 3 into 1 upon 64, that is 1 upon 92. So the 7th term in this series is 1 upon 92, and we can find using mental calculation, as 7 isn't a large number. So for example, 1 upon 24 is the 4th term, 5th term is 1 upon 48, 1 upon 48, 6th term is 1 upon 96, and 7th 1 upon 92. So it is correct. Let's see how to find the sum of the first n terms in a geometric series. That is, you wouldn't like to sit and add let's say 8 and 9 or 15, 20 numbers, and multiplying to find the next number. So there must be an easy way. Let's see what is it. So there is a formula, and the formula says that the summation of s of the series into till n terms is equal to a, that is our starting number, into 1 minus r raised to n. So r is the number by which we multiply every number, and n is the the number of terms we want, and divided by 1 upon r. This is a complex formula, but when we plug in the values, it becomes easy. So we have 5 minus 15 plus 45 minus 135 plus 405. And doesn't this look strange that the signs are changing every time? This is because r is a negative integer. 5 into minus 3 is minus 15, minus 15 into minus 3 is positive 45, positive 45 into minus 3 is minus 135, and so on. So a is equal to 5 and r is equal to minus 3 and n is equal to 5 because we have to find the sum of 5 numbers. And our formula is the summation of series till n terms is equal to a into 1 minus r raised to n up divided by 1 minus r. So we have the summation of the series till 5 terms is equal to 5 into 1 minus 3 raised to 5. And writing this minus 3 raised to 5 is very important, and even here, or else you will get the answer 605, which is wrong. So minus 3 raised to 5 is minus 243, and minus minus will become plus. So it is 1 plus 243, that is 244 into 5, and 1 minus minus 3, that is 1 plus 3 is equal to 4. So 4 and 244 are both divisible by 4. So it is 5 into 61 or 305. Now let's see how to find this sum of a geometric series when n is equal to infinity. That is when there are infinite terms in the series. So you might say, hey, that is infinity. But wait, when the summation of series till infinity is equal to a divided by 1 upon r, only when the absolute value of r is less than 1. So what does that mean? That is the r, that is a number by which we are multiplying should be it can be negative or positive, that isn't the matter, but the matter is that the magnitude, ignoring the sign, should be always less than 1. So what if it isn't? Then we have the formula that states that summation of a series till infinity is infinity when the absolute value of r is 1 or greater than 1. That is, it can be positive or negative, it doesn't matter. The thing is that if the magnitude of this r is greater than 1 or equal to 1, then the sum will be infinity. So of course, we can simply write as infinity when we know that r is greater than 1. But we should try an example where r is less than 1. So the question says that find the sum of 1 upon 2 plus 1 upon 20 plus 1 upon 200 plus 1 upon 2000 till infinity. And does this question ring a bell? This is because it was the last riddle in my previous video. And why is it here? Because it is an example of a geometric series. Here a is 1 upon 2 and r is 1 upon 10, because 1 upon 2 into 1 upon 10 is 1 upon 20, and 1 upon 20 into 1 upon 10 is 1 upon 200, and so on. And here we don't know, we don't need n because we know that it's infinity, and in the formula also n is not there. So the formula is summation of the series till infinity is equal to a divided by 1 upon r. So a is 1 upon 2 divided by 1 minus 1 upon 10. So 1 minus 1 upon 10 is 9 upon 10. So it will be 1 upon 2 into 10 upon 9, because we'll take the reciprocal as this was in the denominator. So 2 and 10 have a common factor 2. So this will become 5. So it will be 1 into 5 upon 9, that is 5 upon 9. And this was the same answer we got in our previous video. So this is correct.
Feel free to ask your doubts in the comments. Thank you for watching this video. Please like and share this video and don't forget to subscribe my channel for more videos.